We're going to look at the second part of lesson 3.5, talking about linear programming. We introduced it in part 1 and did a couple simple examples, and now we're going to get into an actual word problem where we'll have to come up with our own objective function. We'll have to figure out what the constraints are and then go from there, finding the vertices and plugging values in. So here are the steps that we need to go through. We're going to write our objective function for the quantity being maximized or minimized. It depends on the problem which we want. A lot of times we want to maximize profit, and we want to minimize cost. If it is a money question, there's other types, but we often see those. We want to come up with our constraints, the inequalities that we'll need. And then we graph the system of inequalities and find the vertices. And then we plug the coordinates of the vertices into the objective function that we come up with, and then find our answer and make sure we answer the question that's being asked. So here is the example. A company wants to maximize its profits from two snowboards. The first one's Snow Pro and then the Mountain Flyer. The company has a budget of $15,000 for labor, so altogether they can spend $15,000 on labor and $27,000 for their materials. The materials cost $50 for each Snow Pro and $90 for each Mountain Flyer, so that has to do with the materials. And then the labor costs, in order to make a Snow Pro, it's $50 per Snow Pro and $30 for each Mountain Flyer. If the profit for the Snow Pro is $25 each and $60 each for the Mountain Flyer, how many of each snowboard should be made to maximize profit? So there's a lot of information here. We're going to work through these steps that I talked about earlier, and we're going to come up with our solution to this problem. It could be up here, like if we didn't have other constraints, it says we're making $25 per Snow Pro and $60 per Mountain Flyer. Well, this one obviously is making more money, but there's some other restrictions on what can happen with those different snowboards. So let's start with the first thing I mentioned here is write an objective function to be maximized or minimized. So what are we trying to maximize? We can see that here in the last question. What is the maximum profit? So we want to come up with a profit equation that we want to maximize. And so we can first come up with our objective function. And that is a maximization function, or I should say a profit function in this situation. So our profit, what is our profit going to be? Our total profit for both snowboards. Well, profit ends up being the money we make on the Snow Pro plus the money made on the Mountain Flyer. So before we even come up with a function, we have to define some variables. So I shouldn't write this quite yet. So we'll move that down because we have to define our variables here first. So what are the variables? What determines our profit? Well, it says how many of each snowboard should be made. So we're going to find values, or how many of each. So let's just let x, we're going to use x and y because we have an x and y axis. So let x equal the number of Snow Pros made. So our profit depends on the Snow Pros and the Mountain Flyers, and then we'll let y equal the number of Mountain Flyers. All right, so that's what we're trying to find, how much of those need to be made, and then we want to maximize profit. So we'll actually find the profit after we find how many of each. So our profit function, so I'm just going to call it P of x, y, the profit for x and y, the number of Snow Pros and the number of Mountain Flyers. So how much money is made on a Snow Pro? You make $25 each. So what we do for our profit, we'll take $25 times however many Snow Pros are made. If there's 10, 25 times 10, which will give us 250. If there's 100, it'll be 25 times 100. So our profit would be 25x, that's the money made on the Snow Pros, plus 60y. That's the amount made on the Mountain Flyers. So we came up with our objective function. So really before we did that, we even defined our variables, which was necessary to do. Now we want to come up with our inequalities, which represent our constraints. So our constraints, and I'm going to talk through a couple different things here. Constraints actually have to do with 3 different things, 2 mentioned here and 1 just kind of on obviousness. And the first one is we cannot make negative snowboards. So the first thing, I'm going to kind of make little titles here. No negative snowboards. I can't make negative 18 Mountain Flyers or negative 5 Snow Pros or Mountain Flyers. So we can't have negative amount of snowboards, which means our number of Snow Pros has to be greater than or equal to 0. And our number of Mountain Flyers has to be greater than or equal to 0. So x is greater than or equal to 0 really just means I'm over here in this area to the right of the y-axis, and y is greater than or equal to 0 means I'm above the x-axis. So just to start off with, we're in this first quadrant here because we can't make negative snowboards. The other 2 things that they deal with here as we come through, the company has a budget of $15,000 for labor. So there's going to be a constraint on labor. You can only work so many hours or have your workers work so many hours. And then there's going to be a constraint on materials, what they use to make it. So labor, they can spend up to $15,000 on labor. They can't spend more. So we know that we have to be, the labor has to be less than or equal to $15,000. Well, how much does it cost for this labor? Coming through here, the materials, so we don't want materials yet, the labor costs are $50 for each Snow Pro. And so what we do is we do $50. It costs $50 for each Snow Pro, so 50 times the number of Snow Pros, plus, now that we did that, this should be easier to figure out, 30. It costs $30 to make, or for the labor for the Mountain Flyers. So labor on Snow Pros plus labor on Mountain Flyers has to be less than $15,000. Materials. The materials, they can spend up to $27,000, but we want to be less than or equal to that. And we come back and we see the materials for the Snow Pro is 50. So $50 times the number of Snow Pros will be how much they spend on materials for the Snow Pro, plus $90 to make each Mountain Flyer. So those are the constraints. So we have our objective function, we have the constraints, and now what we do is we use these things to help us find our answer. So we are going to graph all of these constraints, and then that will give us our feasible region, and then we'll plug the vertex points into this function to see what our maximum profit would be. All right, so I already mentioned this. X is greater than or equal to 0 means we're to the right of the y-axis. This means we're above the x-axis. So we're in this region. So these are the 2 we want to work with here to find that feasible region. So let's do labor in red. And what we need to do here is solve and put it into slope-intercept form. So we would subtract 50x from both sides. So subtracting 50x from both sides gives us negative 30y equals negative 50x plus 15,000. And then solving, divide both sides by 30, which means we can divide each term by 30. That gives us y is less than or equal to, this reduces to negative 5/3. -5/3 x. 15,000 divided by 30 is 500, so plus 500. And now let's go ahead, and we'll graph that shortly. Let's put this one into slope-intercept form. So we would subtract 50x from both sides, which would be 90y is less than or equal to negative 50x plus 27,000. And here we divide both sides by 90, so we can divide each term by 90. And we get y is less than or equal to negative 5/9 x plus 90 goes into 27,300 times. Oops, 300, not 3,000. All right, so let's go ahead and graph this red one here. We start at 500. Well, we need to count up here. Let's count by 50s. Well, let's see. By 50s. We'll go ahead and count by 50s. So this would be 50, 100, 150, 200. I'll just skip here. 250, 300, 350, 400, and 500. And I'll stop there for now. We'll count by 50s here also. So this would be 100, 200, 300, 400, and 500. We'll keep going. I need 700. So we'll see how that works out for us. Let's go ahead and graph this inequality because of our labor. So in red, we're going to start at 500. And we have a slope of negative 5/3. So negative 5/3 could be negative 5/3, or we could think of it as negative 500/300. So any ratio of this. So we actually can do that. We can actually go, let's just go down 5 spaces. So we can count as spaces 1, 2, 3, 4, 5, and then right 3, 1, 2, 3. Again, 1, 2, 3, 4, 5, and then right 3. So 1, 2, 3. And so we can have a line that goes through those points. And that was a less than sign, so it's going to be shaded below. So right now we're in this triangle because right of the y-axis above the x-axis and below this. And now let's graph our black line here having to do with materials. So we have 300 is our y-intercept, and then we can go down 5, right 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So right there. So we can graph our line through there. So there we have our feasible region, which is, because it's below that, so it's in here somewhere. All right. So in order to find our maximum or minimum, we need to find the vertices, and we have 4 vertices here. We have the point 0, 0. So if we made no snow pros and no mountain flyers, we have the point, let's come over here, 300, 0. We have the point 0, 300. Leave a little space so we can plug it in there. And then we have this point right here, which seems to cause a little bit of a problem because that's not right on a lattice point. Looks like maybe it's like 180, maybe 200, or I don't know, 180, somewhere up there. But we need to find this point. So how do we find where two lines intersect? Well, we can do solving a system of equations. So we want to know where the red line and black line intersect. We can go ahead and take our original equations. I think will be easiest. So we'll take our labor. So it's 50x plus 30y equals 15,000. And then our other equation is 50x plus 90y equals, and I'm putting equals because the inequality doesn't matter here. I'm just finding where they intersect. And now I would do elimination here. Actually, I would multiply the top by -1, so I would make all these signs up here negative, and then add my way down, and this would be 0. That eliminates. -30 and 90 is 60y equals 27,000 minus 15,000 is 12,000. And then dividing both sides by 60. And we get y is 200. Which is interesting because it didn't quite hit 200 here. But maybe my lines were off a little bit with my points or something. So y is 200, and now we need to find x, so we can plug that back into one of these two. Let's take the top one. So we have 50x plus 30 times 200 equals 15,000. So this is 50x plus 6,000 equals 15,000. Boy, what a mess. Equals. Subtract 6,000 from both sides. So we have 50x, 15,000 minus 6,000 is 9,000. And then divide both sides by 50. And we get x equals 180. So this point of intersection right here is x is 180 and y is 200. And that would be our other point that we need to check. So the maximum will occur at one of these 4 points. And so what we're going to do, we're going to come back to our profit function and we're going to plug in. Well, this one is going to be 25 times 0, pretty obvious, plus 60 times 0 is going to be 0. You're not going to make any profit if you don't make any boards. Makes sense. Next one, 300, 0, so we're going to have 25 times 300 plus 60 times 0. Well, 25 times 300 is 7,500 plus 0, so we get 7,500. Our next one, we're going to plug 0 in for x, so we have 25 times 0, which obviously is 0, and then 60 times 300. And that will give us a profit of 18,000, because this is 0 and 60 times 300 is 18,000. And then the last one, we would have, we're going to try this point here, so 25 times 180 plus 60 times 200. So 25 times 180 is 4,500. And then 60 times 20 is, sorry, 60 times 200 is 12,000, which gives 16,500. So we plugged them all in. We noticed that 18,000 is our largest. So what does this mean? This means that we are or this company is best off not make, would make 0 snow pros, and they would make all mountain flyers. So they would make 300 mountain flyers and no snow pros. So how many of each snowboard should be made? 0 snow pros and 300 mountain flyers. And then the profit would be 18,000. And so there's we answered the 2 questions there. Those are 2 answers. So if they were to sell everything, they should make no snow pros and 300 mountain flyers. So we defined our variables. We came up with our profit function, which was our objective function. We had our constraints. We had constraints because you can't make negative of things. So x is greater than or equal to 0, y is greater than or equal to 0. We had our labor constraint, which came from we had to be less than $15,000 or equal to it. And it was $50 for each snow pro and $30 for each mountain flyer. And then we had our constraints because of the materials. Graphed those. In this case, sometimes they cross at a nice lattice point, which is great, and we love that. This time it did not, so we had to find out where do those 2 lines intersect. It was at 180, 200. The other ones were all easy, 0, 0, 300, or 300, 0, and 0, 300. Found this one, plugged those points into our profit function, and found which gave the highest profit.